Welcome everyone. I'm Omer Yair, the Chief Research Officer and co-founder at Raven. So with me is Dejan Lukan, our senior researcher at the team. And today we'll discuss CVE 2025-55182, also known as React2Shell. So let's start. So Dejan, can you give us a brief overview on the CVE?
Yeah, I've been looking at it for the past couple of days, and it's a critical pre-authentication CV that gives you remote code execution. So the flow is inside of the React in the flight component where the deserialization happens. And basically, if you send it the right payload, it can achieve remote code execution without you needing to authenticate. You basically just find a vulnerable application and send it this single request, and that's it. You can get execution there.
So what libraries are affected by this vulnerability?
So these are the React server component libraries, React Server DOM Webpack, and the other React Server DOM libraries. But there are also other libraries because some of them don't actually do npm install and then install the dependencies, but they embed these libraries into their own code, like the Next.js, and therefore also those are vulnerable by default without installing any additional dependencies. Like they have the built infrastructure that will basically just pull down everything and it will embed it into their own code. And there are other libraries like this.
So the main vulnerability is in React version 19, several subversions as well. And every other framework that is using it, like Next.js, which I think is on version 14 and also 15, are affected by it, by this vulnerability.
Yeah.
Yeah, so that's pretty broad. A lot of vulnerable apps out there. So what makes this vulnerability so dangerous?
So the major thing is that you don't need anything. You just need to find the application that uses the Next.js, and you don't need any authentication. You don't need basically any special tools. Just download a script and run it against the website, and it will be, and you will achieve code execution. So even script kiddies can do it. Like you don't need special skills to achieve code execution.
So basically the modern day Log4j vulnerability.
Yeah.
So let's talk about the technical stuff. So how would someone go on researching such a vulnerability to find the vulnerable function and how to exploit it?
And so basically you just ask AI to write you like a test application, or if you are versed with the Next.js, just write it yourself. I was not. I just asked AI to write it for me, and then I ran it in the development mode so that I actually saw the correct names of the functions, and we will get into the names of the functions that are vulnerable in production later on. But those are two different versions of functions. So the production and the development are completely different functions. So you basically run the test application and then you start debugging it. Like I usually just run it in the Chrome in inspect. And yeah, so Omer is showing it now. I just run it in the Chrome in spec. Like this is how I run it, the npx next dev. This will run the next application in development mode. And then if you go to the next slide, yeah, so this is how I basically run it. I just go to Chrome, inspect, and over there I just click a button and it will automatically start the debugging session. But if for some reason it doesn't work, which for me sometimes it doesn't because I'm running this application in a VM, then I just manually get the address of the WebSocket and connect to it directly. And then I can start debugging it. And if the exploit is basically known, I can just use a curl command to send it over to the test application, and I will be able to set breakpoints. And when the breakpoints hit, I will inspect what the input parameters are, how they are handled, and so on. But if the exploit is not known, then you just send some input data to the test application and see how it behaves. And for that, it's usually good to find a patch. So you can narrow down like which functions you need to look at and which functions you need to hit in order to like make the research fast. Yeah, so you need to find the patch like the slide says, and if you can find it, it makes your life a whole lot easier than the Windows vulnerabilities where you usually don't see anything. Like you need to um, reverse engineer binaries and then run it a whole bunch of times to see what's going on and possibly guess what the CVE is about. But for this, it was easier because the patch was available. When I started researching, the patch was there, but the exploit was not. So I didn't know exactly what to send to the application. So I needed to experiment with it and do like the educated guesses. But after a few days, the exploit is now known, so we can send exactly what needs to be sent to the test application in order to cause code execution. So now with the exploit, it's even easier. Yeah, so I have like I made a really simple version of this vulnerability, and I can run it. Omer, do you want me to run it and show it, or just go over the slide?
Let's go over the slide for now.
Okay, so over here we have the get value by path function, and after it we have the data, which is an array of a single string, and then we have the attacker path, which contains some string separated with colons. So we have 0, colon, constructor, colon, constructor. This is important. And then we basically just call the get value by path function. The first parameter is the array with a single string, and the second parameter is what the attacker controls. And this is also what the React2Shell is about. So once this function is called, you can see a loop there, and inside of the loop we first split the reference into 3 different parts. So you see the reference split by column, and then we get an array of 3 elements. The first element is 0, the second is constructor, and the third is also constructor. So while going over the for loop, we first extract the safe value from data. So we get yeah, so we assign the object to value, and then we go over the value and assign the value to itself. So at first we get the safe value from data to get the string, and then we use the constructor, and eventually we get to the function. So we get to the function constructor. So what the get value by path function actually returns is a function constructor. And then outside of the function, we call this function by passing it some JavaScript code. And why this works is because this acts like an eval in most languages, where we can just pass it any code and it will be executed right there. So the first part of this exploit happens when we pollute the value object, and then this value object is returned, but at some point somebody then needs to actually call it. So it's a two-part exploit. And this is how you achieve code execution. It's like evil.
This is a property pollution bug in the React
Yeah.
code. Okay. So let's discuss how you find the vulnerable function.
So one thing is that you search inside of the source code itself, which is not compiled, it's not minified, it's not anything, and there are just normal functions there. But once you actually install the vulnerable library itself, you can go and look at the code and you will usually see that some of the functions are missing. And in this case, you can basically see that two of the functions were inlined into the bigger function. So if you get the stack trace from the running program, then we basically will not see those functions. So just by going through the patch itself and finding the vulnerable functions there, it is not enough. You need to actually install it and look at the installed version to basically get the correct functions out. And some of the functions are also anonymous. So because a lot of the code in JavaScript is async code, so functions will return anonymous functions, and then on the call stack you will just see anonymous, and you can't use that. You need to use like the parent function, which actually has a name. Yeah, so installing it is the correct way, not just looking at the source code.
Agreed.
Yeah, and then besides that, we also have like the development and the production runtime. So on the first slide, we saw how I ran the application server in development mode, where I actually saw the function names, and those were like the model string and so on, like the readable function names. But in production, a different runtime is basically used. So the runtime.prod.js. And this will be a minified version where the function names are scrambled. So they will not contain the readable function names, but will actually contain something like just the letter E or E5 or something like that. So we also need to look at the vulnerable functions over there, and we can do it by basically matching the body of the functions from the production version to the body of the functions. I mean, from the development versions to the body of the functions to the production versions. And by matching the body, we basically know, like, okay, so this body is the same in both versions. So whatever the function in production is, this is the same as in development. This is how you can get to the production function names, and those are the ones that we actually tag and getting the call stack.
So in a sense, if a vendor is looking just at the source code, they may miss the actual vulnerable functions during runtime.
Yeah, so the source code is one thing, then you need to install it, but install it in the right runtime, not the development version, also the production version.
And the function names can also change between versions because the way the minify works.
Yeah, so you need to backtrack through all of the versions and basically extract the vulnerable versions from each of them. So what that means, you need to install every Next.js version and match the body of the functions that are vulnerable, so you can find the function, then just copy paste the function name out.
Yeah.
So you need to automate it, but there is no way for somebody to do it manually. There are too many versions.
Yeah, makes sense. Yeah, so this is what we said. We need to trace back all the vulnerable functions throughout all the versions.
Yeah.
So yeah, that was really enlightening. So thank you, Dejan, for this technical overview. Like, what are your thoughts on this CVE?
Like the standard tools probably cannot detach it. Like the static analysis is one thing, but then there are also WAF, which can probably detach it at first, but as history shows, eventually somebody will find a bypass. Either it will Unicode and encode the character or do a whole bunch of other bypass techniques. So WAF will be bypassed eventually. I'm sure that in the years to come, they will come up with better and better rules, but it's always a cat and mouse game. But the in our detection, like we just get the stack trace, and from the stack trace we basically get the function names, and we can match the function names to the ones that are vulnerable. And if they appear somewhere on the stack, we know that the function was executed. And this also means that nobody needs to actually exploit the function. Like we can know that the vulnerability is there even if somebody is not actively exploiting it. So we can alert the customers and have a little safer world for at least the ones that are using our product.
Yeah, so that's the benefit of using Raven. I want to emphasize what you said because WAF is easy to bypass, and since this is like a normal protocol that the React component is using, you can't write a rule on the protocol itself because then you will block legitimate actions. So the WAF rules try to block the exploit itself in the rule, which is something that you can always change. But I also want to add that on top of the WAF, because this vulnerability is in the framework side of the code, there will be no log because the exploit happens way before the log happens. So there are actually no traces of the application that were exploited by this CVE. So it is very serious and very hard for traditional tools to both detect and provide protection for. So thank you, Dejan, very much for this presentation. Hope everyone enjoyed this technical overview. And until next time. Bye, everyone.
Anytime more, enjoy. Bye.